In this problem, I want to add 57 and 84. I'm going to use the property of equality as well as using the commutative and associative properties. And so we have 57, which is really close to 60. By adding 3 to 57, I'll get that 60. And so I'm going to place a plus 3 at the end of this problem. Now I can't just add 3 to the problem, it will actually change the result. And so if I show a plus 3, I must also show a subtraction of 3 because those cancel each other out. However, that's not really what I want to do. I want to now at this point move my numbers around using the commutative property. And so moving my numbers around, I'll have 57 plus 3 plus the 84 minus 3. So I've switched some places, and now I will regroup so that this 57 plus 3 is that 60 that I was going for. It's a nice round number. The 84 minus 3 will also be added together, actually subtraction in this case because it's a minus, and so I'll have an 81 there. Now from there I'm going to break the 80 and the 1 apart so that I can add these two really round numbers, 60 and 80, to give me 140, and then I can add that 1 at the end to give me a complete sum of 141. In this problem, we have 83 minus 48. And so I really want my 83 to be a nicely rounded number, so I will want to add 2 to that because that will give me an 85, which is a nice round number. And then if I add 2 to this expression, I also want to subtract 2 because in this problem we can't just add numbers all over the place. We have to add equivalent opposites. And so now I'm going to move my numbers around so that my plus 2 is next to my 83. Minus 48 and minus 2 are now next to one another. I've used the commutative property here. And now I will use the associative property to add 83 and 2 together to give me the 85 that I was going for. Over here, it's a little bit different, and we haven't worked with negative numbers too much at this point in the course. We will further on in the course. However, minus 48 and minus 2 combine together to give us a minus 50. So it's sort of like money. If I have $48 that I owe somebody and another 2 that I owe that person, I'm going to owe them 58. And this makes it a lot easier to think about when you think about money. And so now we have a subtraction problem that is much more manageable. 85 minus 50 is going to give us 35, which was a little bit quicker to get to than using regrouping of 83 minus 48 in a traditional manner. In this problem, we have 286 plus 347. Now there's 2 ways to do this. Actually, there's more than 2 ways. We could think of that 286 as 300, or we can think of that 286 as 290. Whichever way and however you want to do this is fine. I'm going to go with my first option. 286, I want that to be 300. 286 plus 14 will give me that 300. Now if I add 14 to this expression, I must take away 14 from this expression so that we can have the property of equality used. So now I will use the property of the commutative property to move numbers around. And when I regroup using those parentheses, those are that's the associative property. And so 286 plus 14 gives me that 300. 347 minus 14 will give me 333. Adding together 300 and 333, we get 633, which is much quicker than adding 286 and 347 using mental math processes. Now, even though I am using mental math processes, I am definitely writing some of this information down. I personally am a visual learner, so I need to write things down. However, there are many people who can do these calculations in their head. For 493, I would imagine that would be 500. So I would take 493 and, oops, 500 times 7 is 3,500, and 7 times 7 is 49. Now for me, subtracting 49 did not make this easier, so 49 is really close to 50, so I may subtract 50 and then add back one more, because I don't want to subtract all of 50, I want to subtract 49. So if I take 3,500 and I subtract 50, I get 3,450. And then if I add one more back, I get 3,451 as my answer. When it comes to division, the mental arithmetic is a little bit more difficult. And so in this case, I want to imagine the 2646 as 2700. And the reason why I want to imagine it as that is because I know that 27 is divisible by 9. And so what I'll do is I will break down this 2646 into 2700 minus 54. And then have that grouped and divisible by 9. Now, the nice and convenient thing is not only is 2700 divisible by 9, but so is 54. And so we are going to do a form of the distributive property with division, which is very different, and we don't do this a lot, but we have 2700 divided by 9. That will give us 300, because 27 divided by 9 is 3, and then the 2 zeros. And then we'll have the 54 divided by 9, and that is 6. And so we have 300 minus 6, and that will give us 294. In this problem, we have 639 divided by 7, and 63 is divisible nicely by 7. And so in this case, I will break this up into 630 plus 9 divided by 7. 630 divided by 7, and I will use the distributive property here and here. 630 divided by 7 divides nicely. We have 90. Sorry, there was a glitch there. All right, so we have 90. And then we have 9 divided by 7. Now, that does not go perfectly, so I already know that this problem will have a remainder. 9 divided by 7 is 1 with remainder of 2. Okay, and just in case you were wondering, here we go. 9 divided by 7, here's 1. Subtract that, we have a remainder of 2. And so we have 90 plus 1 with a remainder of 2. That's 91, remainder of 2.